right, so we're going to talk about sampling. So let's talk about some of our vocabulary words first. We've got the census. That's a survey that includes every member of a population. So the United States does a census every, I think it's 10 years, to see where the population is. And they want to, if you didn't fill it out, like they'll send it to you again because they want to include every member of a population. A representative sample, that's the relevant characteristics of the sample members, are generally the same as the characteristics of the population. So that means the sample represents the entire population because they have those relevant characteristics that they would see in the population. Bias, if the design or implementation of the study tends to favor certain outcomes or results. We will discuss bias throughout the class. So preventing bias is one of the greatest challenges in statistical research. So if you remember from last lesson, I talked about you need to pay attention to some of those key things for vocabulary on your exam. So looking for bias is one of the most important steps in evaluating a statistical study or media reports about a statistical study. So to help prevent bias, it's essential to select our sample appropriately. So you need members of the sample aligned with the population with regard to race, gender, ethnicity, clubs, groups, and so forth. There should be no personal stake in the outcome. The data needs to be collected in a way that guarantees representation of the population, and the data is reported fairly and unbiased. So, first example in this, suppose you want to determine the average, mean, or height of all students at your school. Which is more likely to be a representative sample for this study, the men's basketball team or the students in your statistics class? Well, let's talk about that. So the students in your statistics class is going to be made up of boys, girls, short people, tall people, all kinds of things. But the basketball team, what do we generally notice about them? Well, they're generally taller, right? They're tall people, that generally, not always, but generally you have taller people. Plus, it's only men. Men in general tend to be taller than women. So, which one is going to be more representative? Well, it's going to be the people or the students in your statistics class. It's going to be more closely. So 1.2, example 1. The mean height of the students in your stats. I'm just going to simplify that down to stats class. Is much more likely to be close to the mean height of all students. Because those basketball players are going to tend to be taller, and because they're just boys or males. They're not including any girls in that. All right, number 2. Nielsen Media Research earns money by charging television stations and networks for its services. For example, NBC pays Nielsen to provide ratings for its television shows. Why doesn't NBC simply do its own ratings instead of paying a company like Nielsen to do them? Well, if you remember, we were talking about some bias there up here. So there's the cost of advertising on a television show depends on the show's ratings. So we need to know what the ratings are so that we can charge more for that. Like the Super Bowl, it's really expensive, right? Because it's got high ratings. So to put an ad on the Super Bowl is very, very expensive. The higher the ratings, the more they can charge for it. Now, NBC would have a clear bias, and advertisers would be like, well, I don't trust your ratings because you're saying, oh, it's a high rating, so you can charge more. So by hiring an independent source, such as Nielsen, they can provide that information that the advisors are more likely to believe. So NBC would be looking at bias if they did it on their own, right? So for example, 2, they want an independent source. To provide the ratings so that advertisers are more likely to trust the results. And we could say it prevents bias by NBC because they would be accused of being biased. Well, you want us to pay more, so you're going to say, oh, this has great ratings when it doesn't. All right, example 3. You're conducting a survey of students in a co-ed dormitory in which males are assigned to odd number rooms and females are assigned to even numbered rooms. Can you obtain a representative sample when you choose every 10th room? All right, so let's look at that. The example 3. So every 10th room. So if let me start. We'll start at the 3rd room. So if I do the 3rd room and I'm going to go every 10th, I got to add 10, right? Then I'd have the 13th room. 10 more would get me the 23rd room. And it's going to continue, right? So those numbers are only what? They're only odd, right? And only odd rooms have, according to what they told us, odd number rooms are assigned to males, right? So that means only males. All right, let's start at a different number. What if we start with, if we wanted to start, if it's an even number, like we could start with the 4th room. Then the next one would be the 14th and then the 24th. Well, in this case, we're only getting even, right? And even rooms are only for females. So that's not going to work, right? So the answer here is no. It's not going to be a representative sample because you're only getting males or you're only getting females. Now, what if the next question, it says, suppose you choose every 5th room. All right, let's start at, and we could start at the 3rd again if we want to, or we'll start at 2. It doesn't matter. It'll work either way. So let's start at the 2nd room. So if we start at the 2nd room, plus 5 will get us the 7th. Plus 5 will get us the 12th. Plus 5 would get us the 17th, and so forth, right? We could start at the 3rd room and get the 8th, and get the 13th, and get the 18th, and moving forward. So what happens in both of these, if we're doing the 5th, we end up with an even, odd, even, odd, odd, even, odd, even. So what does that mean? Well, now we're getting a representative sample. This would be yes, because we're getting both both male and females, right? So that we can ask the survey of a more representative group. All right, let's go look at some more words. So random sample. That's every member of the population has an equal chance of being selected to be part of the sample. It's just random. Everybody's got a chance. There are common sampling methods. There's no single method is best as each one has its issues. Some studies combine two or more methods of the sampling, and no matter how a sample is chosen, keep in mind the following three key ideas. A study can be successful only if the sample represents the population. A biased sample is unlikely to represent the sample, and even a well-chosen sample may still turn out to be unrepresentative just because of bad luck in the actual drawing of the sample. So these aren't guarantees, but you've got to make sure your sample represents. So here's some different ways that we can gather our sample. There's the simple random. That's where every participant has the equal chance of being selected. There's no criteria and there's no pattern. The convenient sample is convenient to select. So the subject is coming to you. We'll look at some examples here in a minute. There's the systematic sampling where every 10th or 50th member of the population, which is a pattern. We just did an example of a systematic one where we took every 5th. As far as group sampling goes, there's two. There's cluster sampling. It divides the population into groups or clusters, and then we choose some clusters at random and choose all members in each of the chosen clusters. And then they're stratified. We choose a few participants from all the groups. All right, so let's look at a blown up picture of what we're looking at here on your handout. So this one's simple and random. Everybody's got an equal chance. You just simply randomly choose, right? It'd be like if everybody in our class and I took a bowl and I put all your names in there and I mixed it up and I randomly pick. That's a random sample. Everybody in the class had a chance of being chosen, and I randomly chose one. There's the convenience sampling. So this is a girl, and she's like, hey, do you support the death penalty? She's picking them because they walked by. So that's where it's convenient. The sample is coming to you. This would be like if you're doing a poll at a grocery store. The people are coming to the store, so they're coming to you. Systematic sampling, that's where we're going to select every 4th member. This one says, every 8th member. I was trying to read the writing. In this case, it's the 3rd, right? So 1, 2, 3, 1, 2, 3, 1, 2, 3. This is like the one that we did in an example where we did every 5th. This one, these two down here are the clusters. So these are individuals. These are a cluster or group. So here we're doing a voting, and these are the shaded precincts. We're going to divide our population into the clusters, and then randomly select one of the clusters, and then everybody in that cluster gets chosen. So if we were like on campus and we divided everybody into, like everybody was in a classroom, right? So you're in your statistics class, they're in their English class, there's a physics class, a math class, stats is math, but business class, there's all kinds of classes on campus. So everybody's broke up into groups of those classrooms, and then we randomly chose, like 4 different classrooms on campus, and then we interviewed everybody in that classroom. That would be one way, like an example. And then stratified, you partition the population into at least 2 stratas, like females and males, and then draw a sample from each one. So I might draw a sample of some girls and some sample of some boys. So they're in separate groups. We might look at football players versus basketball players, or we could break it up into business majors versus music majors. Those would be stratas. So let's look at these little guys here. So this is simple random up here. So we're just randomly selecting. There's no pattern. You're not grabbing. These kind of look like they're being a pattern, but they're not. This is just simply just choosing at random some guys to look at in their leisure suit and ask them a question. This is systematic sampling. This is like, here's a guy, and then we did the third guy, and then the third guy, and the third guy, right? So we're doing like every third. This is systematic. This one is stratified. So we took the same guys, and we broke them up into the purple suit, and the black one, and the yellow, and the blue, and the orange, and the green. So we broke them up into groups, some stratas, and then we chose a certain number from each one. So then you're just drawing a sample, and those could be random. So we drew 2 from each group. And then this is a cluster. So I still have them broke up in groups, but instead of picking a couple from each one, I took the whole group, or the whole strata of each one, because these are our stratas. Now I'm taking the whole cluster of them. Everybody in there gets chosen. So hopefully that makes it a little bit clearer. The 2 groups are your stratas and your clusters. The difference between them, here in the cluster, I take the whole group. Here in the strata, I take some of each of the group. Okay? All right. So let's go look at some examples. So we're identifying the type of sampling used in each of the following cases. So this will be example 4A. So the apple harvest from an orchard is collected in 1,200 baskets. An agricultural inspector randomly selects 25 baskets, and then checks every apple in each of the baskets for worms. All right, so they broke it up into 1,200 baskets. So that would be like groups, right? We've got all these baskets. Then they selected 25 of the baskets and then checked all of them. So that's an example like this one here. We broke it up into, here we've got 6 baskets, and then they chose 2 of those, but in this case they chose 25. So they checked all of the apples in the group. So this one is going to be a cluster. So it's in groups of baskets. They chose 25 baskets and checked all apples in the basket. And all is your key word there. Sorry, couldn't see. So groups of baskets, chose 25 baskets. They checked all apples in the basket. So that all tells you it's not strata, it is cluster. All right, let's look at B. An educational researcher wants to know whether a particular college, men or women, tend to ask more questions in class. So at a particular college, who's asking more questions, men or women? So of the 10,000 students at the college, she interviews 50 randomly selected men and 50 randomly selected women. Well, that means how are they going to pick the men and women if they're all in the same group? So they've got to separate them into stratas. They've got to choose all men and women. So here we have lots of groups, but we'd only have like 2 groups. We have the men and the women, and then they're going to choose out of each of those groups. They chose 50 of them, so it's going to be stratified. Because we have 2 different strata. or groups, and then we chose 50 from each strata or group. So we didn't choose the whole group of men and women. We chose just 50. So that's randomly selecting just a few of them. All right, let's look at our next group. For C, in trying to learn about planetary systems, astronomers conducted a survey by looking for planets among 100 nearby stars. All right, so in this one, the astronomers presumably are focusing on nearby stars, right? They're looking for nearby stars because they're easier to study in this case. So what's this an example of? If they're choosing the ones that are nearby, then this is going to be a convenient sampling. Because that's the ones that are being most convenient. If they chose the ones far away, those are going to be more difficult. So they chose the ones nearby in the neighborhood of the planets because that's going to be an easier one to do. All right, part D. To determine who will win autographed footballs, the computer program randomly selects the ticket numbers of 11 people in a stadium filled with people. All right, so we've got a stadium filled with people and we're choosing 11. And they used a computer program to randomly select them. Well, because the computer selects 11 ticket numbers at random, every ticket number had an equal chance of being chosen. So this is going to be a random sampling. All right, so on convenience, we're going to be closest stars. I didn't write a reason. And random, everyone has an equal chance. Of being chosen. All right, and then they chose 11. All right. So they chose 11 of them randomly. All right, our next question is a does it make sense? So I wanted to know, or approximately what fraction of students at my school are left-handed. So I used a convenience sample in which I surveyed all of the students in my statistics class. So it was convenient because they're all in my classroom and I just want to do a survey. Does it make sense? Well, it makes sense that they wanted to do a convenience, so they chose the random. So, this is example 5. So it makes sense. And even though the sample is convenient, so let's write that, it's a convenient sample. Let's see, I think we spelled that one wrong. So convenience sample. It's a convenient sample. There's no reason to think that the students in the stats class are going to differ in any fundamental way from the general population because, there's not going to be that many left-handed people overall. There's probably going to be at least, it depends on how big your sample is, right? So if you only have 5 people in the class, the likelihood is probably not. But if you've got a class with 30 people, you're probably going to have at least one-handed, left-handed in there. So it's probably going to be close to the population. It's probably not going to differ much because your class is very randomly selected, right? So we would expect it to kind of follow it. So probably close to the general population. of all students at school. Now, there's no guarantee, right? We could have a class that all of a sudden happen to have, more left-handed people, but typically that's what we're going to see. And you got to do the experiments to find out, right? All right, so we're going to identify the sample, population, and sampling method here. Is the sample likely to be representative of the population? A pollster conducts a research project about how adult Americans pay their bills. She posts her survey on a website and obtains 47 responses. So we want to know the sample, the population, the sampling method, and is it representative, right? All right, so let's go look at what's going on in our survey here. So a pollster conducts a research project about how adult Americans pay their bills. She posts her survey on a website and obtains 47 responses. Well, the 47 responses are going to be our sample. We'll add from the website, right? Now, the population that she was looking for were all adult Americans. You can't just put all Americans, because all Americans would include everybody, right? And it clearly states how adult Americans. So you've got to, that adult word makes a difference. All right, the sampling method, she did convenience because they came to her. They, oh, and I spelled convenience wrong again. Oh my goodness. Convenience. It's hard when you write and talk at the same time, not going to lie. All right, so convenience sample, because it was the people who came to her, or to, I don't know that it said whether it was male or female, but the pollster, whoever came to the website, so it was convenient on who did that. Now, is this going to be representative? You're talking about all adult Americans, and it's a small sample, right? So there's a small sample. It's a very small sample, actually. And it's limited to internet users. If you are not on the internet, you're not going to be able to do this. So, and they'd have to stumble somehow across our website as well, right? So, not likely representative. Not likely representative. All right, so that's how you're going to be working on these. Now, again, you're going to be working on your homework. Okay, so make sure you're looking out for that. Get your homework done. It's best if you're doing your homework after you're watching the videos, so that way you have everything more clear in your mind, and you're not going like, I don't remember how to do this one. Okay, so do your homework right away. It'll actually help you out a little bit more with being able to do it.